All right, so I'll get started. Hello, everyone. I am Sylvain Lebresne. I work at DataStax and I work in the Cassandra team. So my job is to work in the open source Cassandra project, and so I'm a committer, and I suppose I can say I'm one of the core developers. And one of the things I've worked on recently is CQL, so that's what I want to talk about today. I should stay on the light, right? So that doesn't work. There you go. So what I want to talk about today is first I want to try to explain you at least why we did CQL and the basically rationale behind it. Then I want to show you how it works and explain the principle and how you actually do data modeling with it. In that second part, I won't talk about Thrift at all, so I want to show you that you can explain CQL without Thrift. Then I will mention very quickly the native protocol, and then I want to quickly discuss, what's coming on the CQL front for 2.0 and what's coming after that. So before going into it, I want to do two quick general remarks to be sure we understand what I'm talking about, that you don't think I'm talking about something I'm not. The first one is that presentation here is only on CQL 3, so CQL version 3. We had a CQL 2 before, and before that the CQL 1. There is important difference between CQL 2 and CQL 3, and I won't address it here. So that's CQL 3, that's the version we are moving forward with, and I'm sure if some of it doesn't apply to the previous version, but I won't stay there. The second thing is that what I think confused people a lot, and I'm sorry about it, is that we use the term rows and columns a lot in that presentation, and when I use them, unless I explicitly say it otherwise, I mean CQL 3 row and CQL 3 column. The good news is that's the same thing than in SQL. So I will mean kind of an SQL column and kind of an SQL row, even though I mean a CQL. But that is different from the Thrift notion of rows and columns, right? So the confusion is that Thrift shouldn't have used those names for things that are different from SQL because it confuses every new guy. And in CQL, well, we couldn't use something different because they are really kind of rows and columns in terms of CQL, so we couldn't call them differently. But now it's confusing. So I'm sorry about it, but in that talk, I'm talking of rows and columns CQL 3 way, and hopefully it will be clear how that relates to the Thrift part, and I briefly talk about it. But so let's get into why we do CQL. Well, the gist of it is that the Thrift API is really a very good API. It's not very easy to use. It's not very user friendly, and there's a number of reasons for that. But I think that the main one is that it's very low level. It's very little abstraction. So what that means is that in Thrift, it's flexible. There's no question about it, but everything is hard. So a good API should be it should be easy to do the right thing, and it should be flexible enough so that you can do whatever you want. Thrift is flexible, but in Thrift, everything is hard, right? So you have to piece it together. It's kind of an assembler, in a way. And so yeah, that's very hard. Another thing that we didn't like with Thrift, or one thing that was a problem for us, is that it's pretty hard to evolve, at least in a way that don't break clients. So it's hard to make a change to the API, add a new concept, or an extension to the API without breaking people. Part of it is probably that the Thrift API wasn't designed very well for that. Part of it is that Thrift, the software itself, is trying to target that many languages, so it has to, the feature it has to evolve is like a common denominator on all those languages, so you don't really have optional parameters to function and stuff like that. So at least it's not supported in all languages, so you cannot really use it without breaking people. So really, Cassandra has a reputation of being hard to develop against and work with it, and we believe that it doesn't have to be that way. Don't get me wrong, that doesn't mean that you will come from the relational model and be able to use Cassandra without having to learn anything new. However, we don't want people to have to learn more than what they strictly need to understand Cassandra, okay? Now, the second question that comes is that, okay, fair enough, we want something else that's Thrift, and just adding a few new methods to Thrift won't just cut it. But then, you know, why the hell an SQL lookalike language? It's called SQL after all, right? And the reason is that if you actually look at the pros and cons, the query language is pretty nice. So those are fairly basic, but you know, SQL is very easy to read. It reads like English, right? So you could do a programmatic API that reads like English, but that's a little bit more work. It's harder to make evolve and stuff like that. But it's a given with SQL. The other one is that it's programming language, what I call programming language independent. And what I mean here is that when you want to have help on the mailing list, you can send an email and you can say, here's my schema, here's the queries that I do, and I don't get what I expect, so what gives, right? With Thrift, if you send an email with Thrift code, nobody will answer because nobody will get after the 10 first line, and you will have probably 100 lines because Thrift is that way. So people will send code for Hector or for Picasa, and I have nothing against Picasa, but maybe I don't speak Python, right? So you know have to adapt to all those clients, different and everything. So having a language is that kind of is programming language independent and allow to communicate is, in my opinion, very, very useful. The other one, well, everybody knows SQL, so the syntax is familiar to anyone. That's a good thing. It's copy-paste friendly, so yeah, but it's kind of useful. And one that I actually quite like a lot is that it's very easy to evolve. So CQL 3 in like 1.2.5, which is the current Cassandra version, there's been some evolution compared to the 1.2.0, but those has been very easy. That is, it's very easy to add new stuff without breaking it because you just add new syntax construction that you support. And not only don't you break stuff, but it looks very natural. It doesn't look like you've added stuff after the fact. So that's really good to make stuff evolve. And, well, I'm not done. So, the two other points that, so people tell you, okay, but you're manipulating strings, right? So it's going to be slow, and we don't want slow. But, well, CQL have solved that a long time ago. You just have private statement. So you have private statement, and you pass your value as bytes. So it's not because you're using a SQL-like languages that you have to actually use strings, and you don't even have to work with strings. You don't have to, I mean, people that do SQL every day, they don't do string concatenation all the time. They just don't. So those arguments are kind of not argument in my opinion. So really at the end of the day, why not? Why not a SQL query language? It just reads very well, and hopefully we'll agree that it's not too bad. So and CQL, right? So if I want to describe CQL as like two words, I would say that it's the denormalized SQL. So it looks like SQL, but you really want to modelize things with denormalization. And I'll come back to that. But the first thing is that it's really kind of a subset of SQL because we don't support joins, subqueries. We don't have aggregation. I'll come back to that at the end. And we have limited order bys, right? So we kind of call it strictly real time in the sense that we only support the queries that we know how to do fast. We only do what we can do fast. Now, what are the goals of CQL? So what I've hinted there is that what we want is a user-friendly API that is productive, that allows to do stuff, right? That's all we care about. And what we want for it is to make it easy to do the right thing and to make it harder to do the wrong one. We cannot make it impossible to do the wrong one, but at least we want to make it easy to do the right thing. And that implies giving you higher level construct to work with that just, here, you can store bytes and do whatever you want with that, okay? So in CQL, that means collection I will see, but that's also the way it handles composite stuff and things like that. And the last point is that it is a goal of CQL to be a complete alternative of Thrift, right? We don't mean CQL to be used alongside Thrift. We mean it as a complete alternative, right? You can still use Thrift if you want, but we want everything that can be done with Thrift to be done with CQL. So I know some people will tell me, what about dynamic composite type? Well, you can do dynamic composite type with CQL. We don't have any syntax to do specific syntax to dynamic composite type with CQL, but you can do it. That is, it will look as bad as Thrift, but it won't be worse, and you can do it. And the reason for that is that the dynamic composite type are not that useful. They're a corner case thing. Most of the time when people use dynamic type, they could do it in a much simpler way with a simple composite type, which is what CQL3 gives you basically. So dynamic composite type is very corner casey, and so we don't necessarily provide you a very easy syntax for it, but you can still do it. And then again, we may add one someday. If it proves that there's more use cases than we thought about, and that's more generally useful, and we find a good syntax for it, we may add it, right? It's not the end of the road either. But again, it's supposed to be a complete alternative. No, there are things that are no goals for CQL, and the first one is be SQL, sorry, right? We are not trying to be SQL. Cassandra hasn't been designed to be able to do what SQL exposes, like the joins, the transactions. So we want to do what makes sense. We certainly want to extend the capability of Cassandra. We support compare and swap into and such things like that. But it's not a goal to be SQL, okay? So sorry if that's what you want. That's not a goal. We'll still ask you to denormalize. So there will still be a switch to do from SQL to CQL, but at least we want to make that as easy as possible. The other thing that we don't want to do is to hide the specificity of Cassandra, because then again, the C in CQL stands for Cassandra. So we really want to have an API that allows you to make the most out of the distribution that Cassandra offers you. So you need to be able to work with distribution, and we want you to be able to make full use of the storage engine that Cassandra offers, right? Which is slightly different from it's not a B-tree. It's not a B-tree storage engine, so it stores things sequentially on disk, and people want that, so we want to expose that, and I'll come back to that. And well, the last one, which is kind of the same that the previous one in a way, is that we want to be fast, of course. We understand that you guys use Cassandra because it's a fast data store, and CQL absolutely only exposes things that we know to do fast, and it allows you, again, to take full advantages of Cassandra. All right. So what it is now, what is CQL? But let me just take a step back on how do you model with Cassandra, right? I think that efficient queries, which is what people want in Cassandra, boils down to two things. The first one is data locality at the cluster level, right? So Cassandra is based on the idea that we're distributed. So if you want your query to be fast, you want it to go to only one node, or really one replica set. But if a query needs to fetch data on all nodes of a cluster and join it and do whatever and transfer data between nodes, it won't be fast. So we want you to be able to use that. So you should use data locality at the cluster level if you want it to be fast. And the second one is data locality at what I call at the node level, right? So you want the Cassandra storage engine allows you to do data collocation on disk. It allows you to store data on disk together in a sorted order that you can make use in your application. And you will only get efficient queries if you actually do that, right? And what we use denormalization a lot in Cassandra. Denormalization is really kind of the technique that allows you to have both of those things. Because the reality is that in any generic and useful data model, a given piece of data, it will appear in different queries alongside different set of data. So if you don't copy data in multiple places, you cannot achieve the data locality and on the cluster and the node level, for all your queries. That's not possible. That doesn't mean that denormalization is easy. Don't get me wrong. There's an art in denormalization, because denormalization is not a free lunch. If you denormalize, then updates can become a problem. So it's easy to denormalize immutable data. Denormalize immutable data, that's more of a challenge. So you will still have to, know when you need to denormalize, when it's probably not worth it, and stuff like that. So there's something to learn, but really, what you want to achieve is that. So what we want for the API, all that CQL needs to be able to expose you for Cassandra is how to collocate data on the same replica set, really, on the same node, and how do you collocate data on disk for a given replica set and in a sorted order so that you can query it. And you need to be able to query that data that is collocated in a meaningful way. Okay? And the rest of what the API should do is, let you model your application in an easy way. It should be easy for you to do it. And it should be easy to do that efficiently. And, well, the Thrift APIs allows you to do those things, right? The first one here, the on-cluster localization is like, we call it the row key, and this time is the Thrift row key, right? We call it the Thrift row key, and we say all data that is within the same Thrift row is on the same node. And we do, and the data localization on disk is what we call wide rows, right? The 3 wide rows is just a way to collocate data on disk in sorted order, right? But they are just names. Who cares about names? So, okay. I mean, names are important to communicate, but I mean, what's important is the concept behind them. So CQL, as we'll see, doesn't give the same name to those concepts, but those concepts are absolutely extremely important for a CQL, and they're very central to CQL. Now, to explain those concepts, with CQL, we'll use like a running a small email application. So I will use an example that's naive, because that's just slides and I don't have time to go into all the details, but it's a naive email application. So what I want to store is user first, I want to store emails, and then I want to have an inbox for my user. So an inbox is just, emails received by the user in chronological order. That's what I want to do, okay? How do I store the user profile in CQL? Well, it looks that way. You create a table user, and each user is identified by an ID. I use a UID here because Cassandra is Cassandra is decentralized, and so UID are an easy way to create a unique ID in a decentralized way, so it's a good match. So we use UID a lot in Cassandra. And then I have a number of properties. I have my name, my password, my email, and maybe my picture profile. That's a blob, okay? And maybe some of the user won't have a picture profile, so that can be null. Why not? But at least most users will have that. And, well, my primary key is my user ID because, yeah, that's what identifies my user uniquely. So my primary key is a primary key in the SQL sense of the term. It identifies a row uniquely. Then I can do insert of my user. Okay, so that's a short UID, but that's for the slide, right? A real UID is longer than that, but my slides are not that big. And there is no 3 dots here just to say that a blob is likely to be bigger than that. Okay. You can, of course, also update the user. I can change my email and password for my given user. Now, a remark here is that in CQL, and that's one of the differences with SQL, in CQL, both of those operations are the same. They are both upserts, okay? So what that means is that if the user here, if my user here exists already, that will update my user. And if my user doesn't exist for that operation, it will create the user, and it will only have an email and password, but the names and picture profile will be null, right? So we still support both syntax, and I think it's useful for carrying the intention of the programmer. So I would advise to use insert when you actually mean insert, and update when you actually mean update. But the database doesn't enforce that they are insert and update in an SQL sense of the way, okay? And the reason is that we don't know to do that because Cassandra doesn't do a read when you do a write, so technically we can't do that. And distribution make that even harder, in fact. I think, if I don't forget anything, I see that the only cases where we support something that look like SQL, but the semantic is different. So CQL has additional thing that SQL doesn't have. It also adds additional meanings to some of the stuff in SQL, as we'll see. But I think that it's the only cases where the semantic is slightly different. So you have to know it. But the rest of the time, if you know SQL and you read something that is at CQL, it should make sense, right? Doesn't mean you can use CQL. You have to learn denormalization, but at least it will make sense to you. Now, I've said there is additional meanings to CQL, and that additional meaning in CQL is around the primary key. So more precisely, the first element of the primary key is what we call the partition key in Cassandra. So you will say there's only one element, so the partition key in that example is the primary key, but we'll see example where that's not the case. The important point is that the first element of the primary key is the partition key. And the definition is the partition key, all the data that share the same partition key is stored in the same replica set, right? So the partition key creates a partition of CQL 3 rows, and that's what get in the same node. So that what kind of give you the I can store stuff in the same node if I make sure they share the same key, right? First thing that we want to do. Now, okay, let's say I want an example a little bit more complicated, and let's say that I want my user to be able to create custom properties, right? I want them to be able to go on their profile and say, I want to show my hobbies to my friends, right? But every user could do whatever he wants in his profile. I want to be able to store custom properties. How do I do that in Cassandra with CQL? Well, I could use a map. So we support collections. So in that case, I could just add a column that's a map of string. So whenever my user wants to add a new property, I will insert my properties with whatever I want in there for my user. And well, if I query, I will get that back from the storage. I will have my user that I inserted in the previous slide, and I will have a map here, and I can have multiple properties for each user, whatever. Okay? Now let's store emails. Well, email looks a lot like users. I have a table email, and the emails are identified by the email ID. That time is a time UID, so it's like a UID. It's unique for every. I'm guaranteed that it will be generated unique for each email. But there is a time component here. So that value actually holds the creation time of my email. That's why I will use the creation time of my email in that model, but I don't have a column that's called created at, for example. I could have it. I can absolutely have it. But in that case, I don't need it because I have that time UID. And that's something we do in Cassandra often. But then my email will have a subject, probably a sender, and a bunch of recipients. I can have more than recipients to an email, so that's a set, and a body. I will note here that my sender is a UID, so in that case, I don't denormalize, right? If I want to show an email to a user, I'll probably have to query that to be able to print something that makes sense, the name, maybe the profile picture, whatever. In that example, I've chosen not to denormalize it because probably doing that query is not the end of the world, but maybe in your application, you need to be displaying an email very fast, and you will denormalize. Your choice, right? So that's where it becomes a bit more complicated, but then experiences helps you. You can insert email, and then you can query them. So a remark here is that, well, first thing, we don't do join, we don't do subqueries, so the syntax is just not supported. The other point is that the only queries that CQL allows you to do is the one for which it has an index to work with that's been explicitly defined. So my email here, my primary key here, it defines a primary index, right? So my emails are I index it by email ID, but that's the only index I have. So if I try to do that query that try to fetch the emails based on the sender, then that won't work. It will tell you, no, sorry, I cannot do that, because sender is not indexed, basically. So you can create an index. You can create an index on the sender of emails that will create a secondary index. When you've done that, then you can do that query. But then secondary indexes in Cassandra have their own performance characteristics. So sometimes it doesn't make sense, and sometimes you have to do yourself an inverted index. Then again, you have to learn when you have to do that, but you can at least create the secondary indexes. Now let's get to inboxes, which are the, I don't even know when I'm supposed to stop, so anyway. So inboxes are the more interesting part, and what we want here is that for each user, we want to store the email you receive in chronological order, because that's what we want to show your user, is inboxes. Now, for this application, and that's where you need to know what you're doing, for this application, I will say that I'll need to display the inbox, what I need for each of those emails is the subject and the sender and recipient's names and email, okay? So for example, what I mean here is that I don't need, when I request the inbox of a user, I don't need the profile picture of my sender, for example. Some applications may need to, and they may need to denormalize that part, but in that case, I will denormalize only those parts. I choose that it's enough, right? So if you want to do that, a remark is that in a traditional RDBMS, in an SQL data store, you don't need anything. You have your store, you have your emails, you have your users. Well, you can join them, and with the right condition, you can get your inbox. Now, I don't want to, it won't scale, of course, if you have millions of users and billions of emails. Now, I don't want to pretend that you would necessarily do that, and there's no other techniques in RDBMS. You can denormalize in RDBMS, but my point is that in Cassandra, you don't really have a choice here. The only reasonable way to make it work is to denormalize. And what we mean by denormalizing here is just to basically make sure we precompute the result of the query, give me an inbox. And we want that denormalization to have the two property we talk about, which is we need to be able to collocate all the inbox. For one inbox, we need all the emails to be on one node, because that's the only way it will be efficient to query an inbox. And the other one is that for an inbox, I want all the emails to be on disk in sorted order. That way I can query them exactly how I want to display them. And again, that's what you want when you model with Cassandra. And that's really typically the time series kind of stuff that, Cassandra is well known to do well. It maps very well to Cassandra because Cassandra allows to do that and to do query efficiently. How does it work in CQL? You will create a table that's called inboxes, or whatever, and it will store the email of the inbox. So the first thing is that an email in an inbox will be identified by the user ID, basically which inbox it is. Each user has an inbox. If a user could have different inboxes, I probably would need something else here. If I have sendbox and an inbox, I'd probably have a name here, but here I just have my user ID. And then I have an email ID that identifies the email in the inbox. And that's my time UID that identified my email. And that's my primary key, right? The user ID and the email ID, they identify uniquely an email in an inbox. But then I want to denormalize some parts, so that's the denormalized parts. And with every email in an inbox, I will store, well, the sender email. And in that case, that's a text, because I will actually write the name of the guy and his email. Right? I could store both of them in two columns, but I'll use one here. And I will have the email also, names and emails of the recipients. That will be a set of text. Then I will have the subject, and well, the one thing I probably need is that in an inbox you want to display messages that have been read differently from the one that hasn't been. So I will have an isRead Boolean here, and when I insert a new email in an inbox, this will be false, and whenever the user click on the email to say to read it, we'll just change that, we'll update that value here, right? Now, the thing that makes it work in CQL is that, again, that primary key here has additional meaning in CQL compared to SQL. It is a primary key, right? It identifies my row uniquely. But on top of that, the first element of my primary key is my partition key. We've already said that. We've said that the partition key is what pretty much decides on which node the row will end up. So because my partition key is my user ID, in that case, all the email for a given inbox will be on the same node for a given user, right? That's what I wanted. That's what will make fetching an inbox efficient. And the second part of my primary key here is what we call the clustering column. Actually, clustering columns because you can have more than that. So if you have 3 elements, the first one is the partition key, and the rest is what we call the partition columns. In that case, I only have 1. So the partition columns tell me that within the same partition, so for the same value of the partition keys, the CQL3 rows will be physically ordered following those clustering columns. Okay? In that case, that's the email ID. The email ID is a time UID, and the time UID in Cassandra, they sort by the timestamp that the time UID actually contain. What that means is that for a given user, all my email will be sorted by their creation time, which is exactly what I want. The last small detail is that in real life, you want to display emails in reverse chronological order. So those that were in Patrick's presentation, that is his secret sauce or whatever. So anyway, you will generally query emails in reverse order. We want the more recent first, and then reverse order. So to do that, well, we don't need anything to make that happen, but because we will query them in reverse order, we want to add that option here. And that option here says to Cassandra, I will query my email in descending order most of the time, so optimize for that. I can still query my email in ascending order. I can do it, but it will be slightly less efficient than in descending order, because basically I will do backward 6 on the disk, because it will, on disk, will store it in descending order. Okay? So with that model, I can do queries like get me all the emails for a given user that are older than January 1st of this year, and I want them in reverse chronological order, the more recent first. And how I do that? Well, I do a select. I will, grab my email ID. Here I have an ND CQL3 method that extracts the timestamp from the email ID. So that's mostly for displaying the actual date in a human readable way here. And then I will have the sender email, recipient email, subject is read. And I will grab it in my inbox for my user. And I want all those for which the email ID is greater than 1st of January. But email ID is a time UID, so I need to compare it to time UID. So that's why I have this function here that's computing the smallest time UID that have this timestamp component, right? So it's called min time UID because for a given timestamp, there is multiple time UID that can have the same timestamp. So you can generate the minimum and, of course, the maximum, depending on what you want to do. In that case, what that means is that I will include those that have been done on January 1st, basically. Okay? And I will have something like that. Right. And that's pretty much CQL3. Now, in that inbox cases, in practice, you will have an additional problem that is generally well known to people that have done time series in Cassandra, which is what if that inbox becomes too big, right? We are storing of the email for a given user in the same box, but what if a user do a lot of emails? That partition can become very big, and that's not good for distribution purposes, and there is some performance is concerned too. So in general, when a partition can become really, really big, you want to shard it by some adapted time shard, right? In that case, I will say that I will just want to shard it in a year. So I will only store the email for a given year for a given user in the box, but I will let different years be stored in different nodes so that I can spread out things more evenly, right? I could use a month or whatever. Now, that's my inbox schema here. How do I do that in CQL? Well, I have 2 things to add. I have to add the year column here that will store what year this inbox is for. And I just need to make sure that my year is part of my partition key. So I've set the partition key is the first part of the primary key. You can actually have more than one column composing the partition key, but you have to have some additional parentheses here to say that's part of my partition key, basically. Okay? And that way, I I will only have the inboxes for a user for a given year in Node, but different years can be in different Node. All right, so that's CQL 3. Now I want to say a quick word about Thrift here. So CQL uses the same internal storage as Thrift, right? It's not built on top of Thrift, but it's built on top of the storage engine, but Thrift really exposes like the storage engine API pretty directly, right? But at the end of the day, the data is stored the same way. It's just two ways to access kind of the same data, except that CQL does some it layouts things in a way that makes sense and allows to do more things more efficiently and more easily, right? So in practice, CQL can read your existing Thrift column families. You don't need to migrate or anything. It's a different view. But I don't have time in that presentation to go into detail. So really what I would suggest if you have existing Thrift column family is that fire up CQL.sh. It's our shell for CQL. Just log in into your key space and do a describe of your column family, right? It will show you the CQL definition for your existing Thrift column family. And then do a select star and put a limit because you probably have an existing Thrift column family that has a lot of data in it. So just limit for something reasonable. And then look at it. And my guess is that most of the time it will make sense how CQL actually show your existing Thrift column family. If you do like really weird stuff with Thrift, or if you store in Thrift data like only like binary data, well, that may be harder to read, obviously, but in general, that should make sense. I will mention here that you want the double quotes, and the reason is that in Thrift, the key space names and column names, they are case sensitive. In CQL 3, by default, they aren't. So you need to add the double quotes to make them case sensitive, right? So if your column names are all lowercase, then you can drop those. But you need to add them if you want to make sure that you're actually querying your actual key spaces. Now, you can also read CQL3 tables, or the tables you have created from CQL3 from Thrift. But on that side, I'll admit that in practice, it's a little bit harder because CQL3 has additional metadata. Typically, you give names to things that you don't in Thrift. And because of that, and because we didn't want it to break the Thrift compatibility, we really didn't want it to break anyone that was on Thrift, we don't expose the CQL3 table when you do a describe in Thrift, right? Because we would have to add stuff that are not there for the other tables. So in practice, you have to know how things are laid out to query them. So you can actually do the query. You can fetch the data from Thrift and insert data in CQL3 table, but it's a little bit more advanced. You can query the data, those CQL3 metadata in the system table. So those metadata, you can actually fetch them from CQL by querying the system tables. But then you have to kind of manually, know what you do in Thrift. Okay, so that's unfortunate. But the point is that CQL is really meant to be an alternative to Thrift. It's not meant to complement it. So we don't meant it to be. We don't mean for you to actually use both Thrift and CQL at the same time, right? So that's why we agree that part is kind of not ideal. And we're sorry we can make it much better, but we have problem like compatibility. But really, at the end of the day, you're not supposed to do both at the same time, right? So if you want to use CQL, well, make sure you can access your Thrift column family as you want. Migrate. You don't have to do it, right? If it's working, you don't have to do it. If you're happy with Thrift, then why not? I don't know why you would be, but if you migrate to CQL, and then use that. But don't try to use both at the time. It won't be very, very easy. Now, I don't have time to use into a lot of detail on how this CQL stuff are layout on top of the storage engine. but we've done a bunch of blogs on how that works. So I did a blog explicitly on, you know, how does your thrift, basically what's the result of that for typical thrift column families, right? So I have a blog that explained that. And you know, Jonathan did a blog post also, you know, to show how the wide rows actually translate to CQL. But hopefully, it's obvious that, you know, the CQL, it does expose you all you want to do with wide rows. You can do all the sorting, the same node sorting that you do in Thrift. It's just not called, it's not called wide rows, it's called have a clustering column, basically, for your table. And you have a wide row in the Thrift sense of the term. All right. Very quickly, I don't know if I'm late. Until when is my presentation? 4:10? Okay, fair enough. So I want to very quickly, you know, mention the Nash protocol because it complements CQL3 in my opinion. So initially, when we introduced the first version of CQL3, and that's actually still true in 1.2, we needed a transport because CQL3 is a query language, so you need to ship that that query string to the server, and then you need to ship back the result set to the user. So what do you use for that? Initially, we've reused Thrift, and what I don't mean by that CQL was implemented after the Thrift. I just mean that in the Thrift API, we added an execute CQL3 query method that you could call. So we've really just reused Thrift, the software, as a network transport for CQL. But ultimately, we wanted to move out from Thrift to gain more flexibility, basically. And that's what we've done in 1.2. And in 1.2, we have what we call the native protocol. So the native protocol is really just a binary transport for CQL3. So there is a spec in the Cassandra source somewhere that you can implement, and you can build your own driver for the native protocol that use CQL3. And that protocol has the following properties. The first one is it's fully asynchronous, so you can have multiple queries on the same connection. The goal here is you have a large cluster, you don't want to create a lot of connection from every client to every node in the cluster, so you want to use less connection, but still want to do multiple queries in the same connection. And the other one, the things that we couldn't do with Thrift, probably because Thrift is really RPC based, is that we have server notification. I need to say that so far, the only things that we support is what I call generic cluster notification. So the notification we have is like a new node joined the cluster, and we send a notification. Or that node is dead, and we send you a notification. Because Cassandra knows that when a node dies, other nodes learn about it, so they can actually inform the client. So as an end user, you probably don't care. But for the driver that you will be using, that's very useful because it allows it to adapt. You know, your cluster grows, you don't have to go and change your client driver and add a new IP address and a new Cassandra node to use. And to do that, before you had to do polling, basically. And now we have something kind of more modern. And we don't do things like, as a user, I can ask for a certain notification when some data changes, but at least, I mean, I don't know if we'll do it, but we can do it if we want. We haven't yet decided if we want to do it, but at least we have the tools to make it. And the last point is that it's really kind of made for CQL3, so it's kind of optimized for CQL3 in a number of ways. So moving forward, it will give you a much better experience to use the native protocol just because it's much easier to write a driver for CQL3 using the Thrift interface because it's more flexible and it's made for CQL3. Now, if you want to know more about what a driver that uses that native protocol look like, you want to stay in that room after my talk, and there's a talk by Michael Figuier and Patrick McFadden on the DataStax drivers, and you'll show how that looks. Now, what next? For CQL, well, the first thing is that what next for Cassandra 2.0? The Cassandra 2.0 is coming next month, at the end of next month. the first thing we have is that we have syntax for the new stuff. So we do Cass in CQL3, so we have that syntax, that basically the if here, that allows to do stuff like, update my whatever login table and, set the password for that user only if the user doesn't exist. So that solves my, I want to create user profile, but I want to make sure that I don't create twice the same for the same user, right? And I can do stuff like real compare and swap. So if my email was, that, then I want to change it, but don't change it otherwise. And of course, that's guaranteed to be atomic, atomic and isolated or it's serializable. Let's put it that way. The other thing is that we have syntax to create triggers. So I think Jonathan showed the syntax. I don't have it here, but it's like SQL. Well, again, you have to write Java code to do the triggers so far. We'll change that eventually, or at least make the interface better. But from the CQL point of view, just create trigger, whatever, on some table. Then we have a few things that we couldn't put, or we decided not to put in a minor releases in 1.2 that Cassandra 2.0 will have. So the one is, there was a few stuff that in 1.2 you cannot prepare. You cannot put a bind marker for some of the things. And those things are the timestamp, even though in CQL3 should probably just let CQL3 pick the timestamp for you. But the TTL and the select limits, you couldn't put a bind marker and just execute it with whatever value you wanted. So that works in 2.0. That one is primary key column secondary indexes. In Cassandra 1.2, you can create a secondary index on a column that is not part of your primary key, but you cannot create a secondary index on a column that is part of the primary key. In 2.0, you will be able to do it. So that sometimes that can be useful. You want to create an index on a clustering column, typically. And the last one is we support alter drop that allows to drop CQL3 columns. And I'll get there, but we couldn't do that in 1.2. We also have a few changes that are kind of nice for the native protocol. So we actually have a version 2 of the native protocol in Cassandra 2.0. So Cassandra 2.0 will support the version 1 of the protocol, but it will also support that version 2. That are those new features. The first one is it's a prepare and execute messages. So sometimes you don't want to prepare a query because you will execute it only once, but you still, maybe you have blob data to insert and you don't want to serialize it to strings, so you want to send a query with bind markers and the values and just have it executed without doing a round trip of preparing it. So we have that in version 2. The second one is that in 1.2 you can prepare a batch statement, but you cannot execute prepared statement as if they were in a batch, and you can do that in 2.0. We also switched to SSL authentication because honestly the authentication of version 1 is kind of crappy, so we have something that's more standard. And the last one, automatic query paging. In Thrift, and so far in CQL, if you have a query that can give you a lot of results, you want to page it just because otherwise you'll OM, either client side or server side or whatever, right? So with that version of the protocol, we'll do that pretty much automatically server side, right? So the result is that with your client, you'll be able to do a select store on everything, and you'll be able to read all your database if you want. It will take a lot of time, and that's probably dumb, but you will do it without OMing, at least. So that's cool. And that's what after Cassandra 2.0, well, really, what we're going to do is to continue to improve that user experience, to make it easy to do good data modeling, to promote the good things. But we absolutely, it's really an API for Cassandra. We don't want to be unfaithful to Cassandra in a way. We really care about Cassandra, and we don't care about SQL. It's not, we know everyone knows SQL. We want to make it easy to be productive. But what we care about is Cassandra. But more specifically, there's a few stuff that I personally want to work with, like storage optimization. So because CQL3 layouts thing in a way that we know, that we control, we can do actual optimization based on that. And then The one thing you cannot secondary index, even in 2.0, is the collection. We don't have secondary index on collection. We will add it, but it will come after 2.0, unfortunately. And then we've discussed doing aggregation within a partition, because we could do that fairly efficiently at the end of the day. So we'll probably do that at some point. And then there's one I want to do is that make it easier to create like user-defined type that are kind of tuples in CQL3. I think it would be useful, especially with collection, but more on that another time. So thank you, and if you have questions, I think I have barely time for questions, but yes?
Before the questions start, we only have time for about 5 questions, and then...
Okay. I'll be outside after the question section if you have any question I haven't time to answer. And so I'll take them in kind of order. Sure?
Can you go back to the email example slide real quick?
Absolutely.
So my question is, you have the partition key and the clustering one where we show data. Yeah. So the partition key is the row key. How is the rest of the data stored as name value pairs in Cassandra's storage engine? A column name, column value, because you said it's sorted by the cluster key.
Absolutely.
But the rest of the columns will have the same name, but different values. How does that work?
So basically the way it works is that the partition key is the row key, and the clustering column is pretty much the internal column name, right? So when you do in Thrift, when you do dynamic rows, you use the column name as a value. That's basically what you do, right? It's a timestamp or whatever. And in CQL3, we just show you that value as a value because that's a value. So that's email. Here I don't have my row, so it's one partition here. And my email ID will be internally my column name. So now the thing is, for a given clustering column, I can have multiple values here, right? For an email, I can store multiple stuff. And the way it works is that the actual column name will be a composite, where the kind of first element will be this, and the other one will identify what's the actual, things that. So a CQL3 row is a slice of internal column internally, right? And that's kind of what you would have done with Thrift if you do it right, because here, right, you need to be able to update that independently of the rest. So if you put everything in a blob, that will kind of suck. So that's what you would want to do, but we do it in a much more easy way. So sorry, there was.
Specify consistency level.
Right, the consistency level is not in the CQL3 language, it's at the transport level. So when you have your client, you will do execute that query at that consistency level, right? So it's not in the language, it's the transport. That's part of the transport. The native protocol specification tells you execute is a string, a consistency level, right? Because it's kind of, the consistency level is kind of what it influences the operation, right? Not really what you store in disk, because you store the same thing. It's when you actually get back the answer to the client. So we figured it's more related to kind of it's external to the actual operation. Anyway, we made that choice.
So I won't be using KDBC.
Or you'd have to, well, you could do that. There is a GZBC kind of driver for that. I imagine you'd have to have some option somewhere that sets a default consistency. It probably won't look very well if you want to change the consistency level per query. That's why, that's why in the Java driver, if you look at the Java driver for CQL3, the API kind of look like GDBC in a way. It's not super different, but Cassandra is different, so we wanted something that's different. And we will probably do a GDBC layer for compatibility's sake. But if you really do, again, if you do Cassandra, you're not doing SQL, so you should probably use something that's adapted to that. I think it was question.
Is there any plans to do column aliasing? So the column names.
Yeah.
You already have an email ID. It's sort of there is no email ID, right? Because that's just in the metadata.
Yes.
So why not do the same for the rest of the columns so you can have really short columns?
So we probably won't do it that way. What I want to do is that the storage. Oh yeah, sorry. So the question was, because here like email ID is really kind of a metadata, not an actual name, why not do that for the other columns so that we can have meaningful names here, but internally short names for storage reasons, right? And the way we want to do it is that that's the storage engine optimization I was talking about. We don't want you to actually, what's the point of having you declaring the aliases? You've given us your column, so we can create that aliases internally, and we will do that, basically. Yes, we will do that, but behind the scene. We'll optimize internally. But we do have aliases support for selects. So typically here, I could do, you know, date of as date, but that's just to have a nice name here. So we have some aliases, but that's just for queries. There. Okay, last, and I'll be outside for the other ones.
How do you store the columns in the initial storage engine data?
Why didn't we think? So that here, that's not really a column internally. That's okay. That's email ID is not storage, just the metadata, and that will end up being the column names. But that will be stored as part of the composite name of the column internally, and that will be the value of the internal column, right? So it's allowed that use the composite type, which is what we tell you to do in Thrift anyway. All right, and I think I have to stop here, but I'll be outside. Thank you.